Hey guys, welcome back to the channel. This is Paul again. It's a quite long time, guys, that I'm not active here in our channel, here in Maharlikans code. So probably because of the what do you call this, work-related things, guys, that I'm keep busy one of these days and a few months as well. But right now we have some time that we can discuss and share it again, some of our Golang knowledge here in Maharlikans codes that we can share up to all of you guys out there. And by the way, how are you guys? And I hope you're fine, you're okay, and wherever you are in this world. So this is my new settings now, guys, in the Philippines. So it's just in my house here, so we can discuss it again. So currently we are working from home, and as of today we are November 30 as of this recording, that currently we are having some public what do you call this, public holidays. So it's just one day. So and then finally, at least I have some time again, guys, to share it with you, some knowledge here in Golang. And yeah, and then right now we need to we have some topic here to discuss. This is a very important topic, but before that we need to shout out those people that who are currently commenting in our last video, since this one is last April 15 that I publish. So currently there are 5 people who are currently messaging with us here. So first of all, number 1 is RN, who is it says that great contribution. This series will be a good reference. Thank you so much, RN. And the second one would be Jarobik Faiziv. Hello. I didn't follow previous videos, so I'm just curious what DB did you use. Thanks in advance. So I really replied Jarobik that time. And thank you, Jarobik. And also Ibrahim Sulaiman. Great effort, thanks. Thank you, Ibrahim. And also the last but not the least, sorry about that, I don't read it properly. Is it 0 or so come back, please. So right now I'm here. Thank you so much for your comment, guys. And special what do you call this, my colleague in our office, although we are currently work from home, so who is RV Diaz and Ray Raffles, and also to my brother Bernard Peligro. Okay, so that's it, guys. And today we are also discussing regarding this very important topic. As I mentioned, we are currently having this Argon2. If you encounter this one, this is the latest, or not so latest, guys, but the recent recommendations of password hashing for any kind of a password. So it was written originally by the Russian people here. Last time it was 2015, and this Argon2 is won by last July 2015. Yeah, so it is a key derivation function that was selected as a winner of the password hashing. So it was recommended nowadays, guys, since 2015 that they won this password hashing competition, and then it will be the standard, the world standard for using this for hashing any kind of a password. whether in our web application, your application, or whatever kind of a password hashing, guys, that it is a very secure, and then the modern way of doing this, originally written in the C code, but already supported by Golang itself. So it's already built in Golang. They call it Argon2. So we will be discussing this, and then we have some package that we need to develop and then already publish, and then we will publish it on our IT Republic GitHub, so that you guys out there, you can use it freely. It's under MIT license. And of course, don't forget to subscribe my channel, guys, to honor our work here in Maharlikans code. Okay, so let's dive into this tutorial, guys. Okay guys, so welcome back to our channel. Okay, okay guys, again, this is the setup. Initially we will put some main.go here. By the way, we can rename this later on, because we need to deal with this Argon2. So I just name it Argon2id, guys. Okay, so this is our file name here, and then we will be creating this new package. But before that, it's just a brief introduction again, guys, for this Argon2. Argon2 is a key derivation function that was selected as the winner, guys, for the password hashing competition in last July 2015. So it was designed by these people here, guys, so in the University of Luxembourg in yeah, this one, guys. And then this is the originally it was written in C code. So this is the original C code here, which is the winner Argon2. So this is the newest standard for password hashing, guys. So it's more secure than a bcrypt. Bcrypt is it was last I think it was started on 1999, guys. So it's quite some time now. How many years passed? So the newest technology for password hashing, guys, is we call it Argon2. So okay, so also this is the built-in package for Golang library, guys, for this Argon2. So as I mentioned earlier, Argon2i and Argon2id. So there are three variants, guys. I mean two variants for this Argon2i and Argon2id. But we are using this ID key, which is a combination of both those both these world, guys, these methods. Okay, so these are more secure and more on the memory side. So that's enough for this package, guys. We will start creating and building our newest package called the pwd. But before this before this, we need to create a new package here. Go mode init GitHub, because we are publishing it to GitHub, guys. If you are developing, again, just a quick overview. If you are not familiar with how to publish new package in Golang to GitHub, you can take a look on my previous video regarding this, on how to publish Golang package, guys, to GitHub. So right now we are publishing to GitHub, so we need to address like go mode init github.com/ your GitHub channel there or something, your repository republic, IT republic / then our newest repo name, which we call it pwd, guys, in short for password. Okay, so go mode init, and then already created a new go.mode here. So our latest version as of this recording, guys, is Go 1.17. So okay, guys, by the way, we need to create a new struct here first, guys. We call it for Argon. This one, Argon2 requires configurable variable, guys. So we need to deal with this one first. They have the memory as if as it mentioned in this thing, guys. As you can see, that this function id key, it requires a password, the plain password, the salt in byte, time, which is the iteration, memory, which is how many memory allocations that we need to save it. Like for this example, guys, there is a 64 times 1024, so this is an equivalent of a 64 MB of memory that it can generate or use to generate a password hash. And then of course this the parallelism, which is the threads of how many cores that you are using, guys. And it depends on your hardware requirements. So the more you have a core CPU there, then you can configure these variables, guys. So this is what we are going to do for this Argon2, as we need to set up this configurable variable, guys, so that you guys out there, you can use freely the package, and then after that we can just configure by your own. It depends on your memory usage, but the standard way is this 64 times 1024, which is the 64 MB, guys. And then of course the last one is the key length, which is 32 bytes by default. Yeah, this is the decent amount of configurations for the Argon2id key. So right now we need to deal with this Argon2 configurations, guys. So this one is a uint 32, okay. And then another one is the iterations. We call it iterations, guys, instead of the time. By the way, they are the same there. Thanks to Edward for the inspiration of doing this Argon2 password hashing, guys. So okay, so you can read most of their contents there as well. And then another one is the parallelism. Also this one is found in this C code, guys. These are all the settings here. The iterations, the parallelism, the memory, which is in KIB, and then the hash here. So these are all the examples, guys. So it is already exists in the Argon2 as well. So in the original C code, parallelism. So uint 32. I think this one is a uint 8. Yeah, it's just a small thing, guys. And then salt length, which is a uint 32. And then also for the key length is a uint 32 as well. So it's my SOS thing. And then these are all our configurations, guys. By the way, we can also put some constant here, so we can put our default Argon2 configs. So these are all constant here. We can put the memory uint 32. Then we can assign a constant value of 64 times 1024. Okay. Yes. And then we call it iter for uint 32 as well. Is we just these are all the default, guys. You can change in later in our configurations. Parallel, this one is a uint u. Don't have to know how to type now, guys. And then the another one is for the salt length. which is uint 32 as well. So this one is 16, and then another one is the keylen uint 32 is equal to 32 as well. So now it's a good thing here we have done. And then also we need to check this one, if hold on guys. So right now we need to create a hash password here now guys. I mean for the function, this one is for hash and salt, so we call it hash and salt. That means we need to create Argon2 hash now guys. So this function is the main purpose is to generate a hash string. Okay, so and then we require we return string and then error. Oops. So string only. I always have this typo now guys. So we call this as a thing, and then we call it salt bytes. I just return with nil first guys, and then nil at the moment, and then we call it the salt bytes here. Salt bytes make, and then we can put a byte here, and AGC, and then I need to initialize the AGC first guys, for this Argon2 configs here. So I just initialize it with var AGC is equal to this Argon2 configs. So we have this, and then this one we can create a new one here guys. So we already have this memory here, the default values, and then of course we continue this hash and salt. So this one we call it the AGC here. Later we will configure this AGC guys to initialize these default variables here. Okay, we use run.read. This is a salt bytes here. So if error not equal to nil, then we can use this return blank, otherwise we just return error. And then the next one we can this one we can generate the salt byte here guys. This is the main ingredients as well guys, because this one is a secure read salt bytes. It is a random strings, cryptographic strings to generate a secure random for our salt. So again, this one is Argon2, and then okay guys, so we will create a Argon2 hash here, and then we will be dealing with Argon2. So to capture our time guys, by the way, we are using this what you call the copilot in GitHub guys, to auto fill in our thing guys. So we don't want to repeat keep what you call this, repeating those common tasks, the autocomplete thing, so to capture our time guys. So you can install that in our install this in the VS Code. So okay, I just need to reload my thing guys, hold on for a while. Okay, so thing is back. Argon2. Okay. Iterations, maybe just want to func return error return string. Hold on guys, because I'm using my old laptop guys. I always have this is a problem with the old and new laptop, so there's a problem in the keys are the rearranging the keys. You always, when we save, there's a problem. Okay, so okay, so this is the return here. I think I need to go mode thing guys, because there's some error here. Go mode vendor first guys. Go mode vendor. Go mode tidy. Okay, so Argon2id password pwd. I think it's fine. Yeah, and then after this we can create a b64 here. We need to encode b64 salt, so luckily this one guys, and then another one is a b64. We are generating Argon2 Hash. Okay, so this is the thing. We need to use row standard encoding guys for the base 64, and then because this one is an unpadded one, so no padding for those bytes guys, so we don't add the padding. So we need the original sensitive information from this plain password guys, because we are translating this into a byte, something like this Argon2id key function is returning. So right now this one is a byte now guys, Argon2id key. So okay, so Argon2 hash. Okay, my S, pardon with my S guys, I always save this. And then after this is the hash. I need to fmt.Sprintf. We need to do some combination with this one guys. This Argon2, there is an Argon2 in every password that we are generating guys. So and then concatenated with this, there's a time here. We need to save this information guys with the current version once the password has been generated, or the hash key has been generated with this one. So there is a key for this Argon2, which is a standard way of like this from the C code. They originally have this Argon2 keyword here, and then the version 19, which is the current version of that Argon2 that you are generating or using the package, and then the memory that you are using, which is a 64 MB, the time, which is the iteration 2, which is a constant value, or you can change as well, and then the parallelism is 4, the threads, and then this one is for the hash, the salt hash guys. So that would be the thing there. So right now we are generating this, and then we will copy over this one, copy, and then paste it here. Yeah, this hash. So okay, save. What could be the problem of this one? So right now we need to okay guys, we have done this part, and then there's the error here. We need to go mode first guys. Go mode tidy, and then after this to collect all those packages, guys, and then we have some vendor here to store all those libraries. Go mode vendor. So we already have all this information now, and then okay, so we already have this hash and salt. Later on we will put some notes, guys, to capture our time. All these informations, no worries, because we will publishing this into our IT Republic GitHub. So right now we need to put some test for this one, guys. So we need to create a new file here, Argon2id underscore. We need to put some test cases here, guys. So package pwd. Okay, so we need to create a func test, this one, hash and salt. So we are about to generate those hash and salt, guys. So right now we don't require this. Oops. So this salt here, and then by the way, before we can do that, maybe we can, I will create some initialization first, guys, because right now we don't have to deal with these default values first. So because in our test here we need to create we need to supply those default values or your customization, guys. Okay, so okay, guys, to capture our time, I prepare this one for you guys. So I just explain it a little bit further, and also I supply all these important notes here so that we can trace whatever these code lines are doing, and what is the purpose of that one. At least we have some decent information there, guys. And also I supply all this information, the raw RW mutex for this Argon2 configs, guys, because we need to initialize this one, this default. We need to supply this defaults to our Argon2 configs into our struct, and then after this, the initialize Argon2 configs will have some another function that I prepare also, guys, to capture our time, guys. So pardon me for this one, because I don't want to make our videos too long. It's too boring if it's too long, guys. So I just explain further. This one I created. This one we have already previously doing in our ITR log, so you can use that one as well there. So it's the same thing, same pattern. I just replicate it here, and also in the func init, we are initializing these values and supply all this information to our struct here. So these are all the informations, the default values. Of course, we are loading the default values from our constant variables there. So which are the memories, the iterations. These are all the default, guys. But later on, you can customize this one. I will show you later in our unit testing if we can deal with these set Argon2 configurations. Most especially, of course, you need to change. It depends on your memory allocations of your hard drive, the threads, how many parallelism there. So you can supply all those informations like these iterations, and then the memory like 128 to 56, all these things, guys. And then we come back to our test. This test right now is we need to generate a new password, guys. So by the way, this is your plain password here. I just want to change plain password. So this is your plain password, for example, guys. Is just to simulate like we need to generate this kind of hashing here in this one, I mean in the C. So we need to generate like this type of hashing, guys. Okay, so we come back here again. After this, I need to copy this. By the way, I'm using the Windows terminal. Here, guys. You can download this Windows terminal in the Windows terminal there. You just search in the Google, guys, rather than using the CMD or PowerShell. This one you can incorporate everything here. like a Ubuntu, Azure, or whatever, guys. So this is a more modern way of doing this. Okay, I need to go test. We run this function, guys. So right now they are generating this Argon2 password. So as you can see that this is the result here, Argon2.go 18. So the hash one, so because we are hold on, this one we are generating here in the log f. So this is the thing now, guys. As you can see that this is the hash key from Argon2id function has been given to us. So this is the password that we need to store into our database for each user or something like that, guys. So you can store this string. This is a string now. You can save it if you're using MySQL, SQL database, or NoSQL, things like that, guys. So you can store this password now for each user. Okay, so nice and simply done here, I suppose. Okay, guys, so we are generating now. Our next step would be to validate this hash into whatever the hash that we need to compare this hash, guys. Okay, because there's no way that you can decrypt that hash. Okay, so the next thing is we need to create a new function here to compare those hash keys. We call it the func. Okay, to capture the time again, guys, so I added this decode hash password and check password. So this is the main function that we need to check or compare our Argon2 hash key, guys. So every time there is password validation, there's no way that we can decode back or decrypt back the hash key, guys, or whatever the password that we are generating from the Argon2. So there's no way of decrypting it back. So there's a one-way ticket only, guys, as we have mentioned. So this one is the main check password hash. This is the thing that we need to compare the hash one, guys. So what this function actually does is we also accept plain text password here and then the hash key. So right now and also I added this test check password hash. So we need to generate the password again for this Argon2 hash. By the way, guys, the Argon2 hash is every time you generate it, the strings that we are generating it will be different way again, guys. So the only way we can compare the hash is by generating the hash key by itself again, and then the magic will go on using this subtle function from a cryptography from the crypto function, the package from the Golang itself, guys. So it's a built-in library, so it's a more secure way of comparing a byte to a bytes, guys. Compare two bytes. So if it returns 1, that means it's a valid one, guys. So you can return through here, and then if it returns 0, that means it's not valid password, guys. So we can test this along later on, guys. And then there is the code here. So that's why we need the hash here, because we need to get the previous hash. So whatever the password, we stored that hash, right? Remember that we stored that hash into our database. For each user, there is a username and then the password, and then we store this hash here. So we need to decode back this. We need to extract the things here, guys. So like this Argon2 and then the version, and then we need to validate the version, and then the time here, and then of course the password here. So this one, it will change every time we generate, although it's the same plain password, but of course it will generate another strings because of that salt that we're generating is a very unique and secure way of generating random cryptographic strings. So right now, this is the magic happens, guys. After we generate, we get we need to get the old hash key here that we stored in somewhere else, and then we generate back again the same key. Same function, Argon2id key, and then the plain password, and then the salt here or whatsoever, guys. So the salt that we are decoding from the hash password here. So we extract back the salt, okay, and then the iterations from our memory here, guys. Okay, so whatever that we are storing, so it's also decode back again, guys. Those what I call especially this salt, and then all those thing. Okay, so and then the magic thing happens here to compare both hash. This is the byte here and then another byte here. It returns 1 and then it will return true, so it will be the password that thrown by us to compare in our application will be it is a valid or not. So this is the key ingredient here for our to verify our password, guys. Okay, so this is the decode hash password here. Okay, so these are all the standard way here. Just split those string, the dollar sign. So every time there is a dollar here, it will be splitted. Like this one, split this Argon2, so we will get Argon2id. These are all 6 split values, guys. So up to 6 arrays. So the index. So another one for this one is to get the version that we are generating, version of the Argon2, and then the iteration. The memory, and then the iteration here is how many we define for the time constant, and then for the salt. So these are all the thing here that we need to extract, guys, using this decode hash password here. So these are all total 6 values here. So after that, need to check the current version at index 2, which is this one, guys. This Argon2, this is the index 2, which is the v19 here. So this is the current version by using scanf. So we can extract only the 19 value, for example, of this time. No need this v dash, no need. So we just get the value of this, which is the 19. And then after that, we compare the current version and then the Argon2 version, if it is correct or not, and otherwise it will throw some errors here. So again, the next line would be the decode here, the scanf. This is what I call to decode the parameters, guys, as I put a note here. And then after that, we will this 3 is something like is M, I suppose. So we can no worries, we can just extract back. We can fmt here, so to ensure everything is in place, guys. So we just print the vals or something. Okay, vals, then 0. Okay, then fmt.Println val1. Just put everything first, guys, so you will know what is that thing. So it starts by 0, so end up with 5. So need to test this one, guys. So by the way, we need to test this one first. So this is to compare the plain password here. This is the password, your password, or whatever the user's password here, and then of course this is the password here again. So right now we intend to match everything first. Later we will try to make it wrong at some between these two. Okay, so we will test first and then see the result for that thing. Okay, let's see if it returned true or not. So right now, as you can see that right now, as you can see guys, this is the the array 1 0 is Argon2. Also our password is correct guys. Okay, if I make it wrong, hold on guys. So now the password is not correct guys, so it's a mismatch thing. So if I run it again, the test, so it says incorrect, so it failed our test here. So right now is incorrect password because password 1 and the plain password without 1, so it's a mismatch guys. So our function now is totally it's working. And also this Argon2id is the val0, this is the version here, and then the val2, so this is the memory 3 4 and 5. This is the thing, our salt here. So this is the 5, this is the salt, I guess. I need to go back again, so maybe we can put something else. This is the vals 0, so we will know guys exactly the thing. Print line, hold on guys, I just change later on. Okay, so this is 1, this is 2 3 4 and 5. So we will test it again. So for val 0 is empty here, so start with val 1 is the Argon2, and then the val 2 is the version of the Argon, and then the memory, all these things, they are all combined already in one string guys for val 3, value 3. And then this is our 4 is our thing. Hold on guys, 4 is the to decode the salt here, and then the last part is the key. So remember when we have this our value here, sorry guys, we need to scroll up. This is the memory here, so we are putting all the memory. The key length is 32 and then the salt length is 16. So that is the value for the vals 4 and the vals 5 is the key length. This is the salt, so we can decode exactly the things guys. So we can just remove this. So right now our test is working fine. If I put back the correct password, now it's all match. You can use this function guys, check password to check the hash to hash guys. So right now I need to clear it, we run it again. So the test is now passed, and then the password is correct. Okay, so all match guys. So I think that's it guys, and I hope you enjoy here and learn a lot here in Maharlikans code guys. And after this, to capture our time, I already published it into our IT Republic guys. So you can grab this code here. I mean you can install it in your package guys, in your Golang. Visit this github.com/itrepublic, then pwd. So this is the a helper function for Argon2 for this one guys. So I also put some useful examples here. For example, in your package main, there is an initialize here, the func init. So this is how you can customize the values guys. For example, I put 128 here or 256 or whatever it is your machine requirements or your business requirements. Okay, so you can change all these parameters here. and then after that you just initialize it in func init, and then after that as you can see that how you can generate an Argon2 secured password here. So this string here is the Argon2 hash. You can store this into your database along with that username, and then after that when the user log in or something to verify that hash stored in your database, this is the second function that you need to do, guys. So to ensure that is it the password correct or not, so by using this pwd.CheckPassword_hash, so your plain password here that to compare with the hash that you are generating from your database. Of course you need to fetch that whatever you whenever where it is stored in your Argon2 hash, like in this case this is the thing that you need to store somewhere else, guys, most probably in your database. Okay, I think we are done, guys, and don't forget to subscribe to Maharlikans Code for more videos, guys, and to honor my work here in Maharlikans Code. Thank you so much, guys, for watching this tutorial series here. Hi guys, again thank you so much for watching my tutorial video here in Maharlikans Code. I hope I impart with you some knowledge and on how to deal with this Argon2, which is the newest standard for password hashing. So it's a more secure way, guys, as I've explained to you earlier. So probably in our next video, guys, I will be sharing, if you are not encountering yet, we call it an API. So it's an application programming interface. So in our previous videos that we are dealing with the standalone kind of an application. What I mean is nobody can use externally, like other developers or other applications that might be integrated with our applications. So they will get a data of our API, and then they can use it. They can pass on a JSON data or a JS1 or XML file. So we need to deal with that kind of an architecture, guys, because this is a more robust, so that every time you develop an application, a software, we ensure that this is an API ready. So at least in our own way we can explain how to deal with this, how to design our application in such a way that we can share, or we can impart some knowledge. We can impart those technologies that we are creating, and then after that other developers can integrate with their own application. At that time I will explain further, guys, so stay tuned for that video. So we will be creating in the simplest way, and of course we need to pass on JSON data, and then by using Postman to test our API. So for example, like we need to pass on data such as like create a new user, for example. So in such a way we design a system that it can handle external requests, of course. So but in that case that is too advanced yet, but we need to make it as a basic first. At least we can I can share it with you, the foundation of it. Then you can expound your API or whatever you are building it. So we can do that, guys. So stay tuned for that. Okay, so that's all, and thank you so much for watching, guys, and please consider subscribing to my channel, guys, to honor my work here in Maharlikans Code. And of course bye for now, guys, and see you in my next video. Thank you so much, guys. May God bless us all. Thank you, and bye bye. Keep safe, everyone.